Hi there, welcome to Spark Genius Academy with Polite. So thank you very much for joining in on the lesson, and we're gonna work on this past paper. If this is your first time watching our lesson, please make sure that you hit that subscription button so that you can get a notification when we upload the next lesson. Please trust me, you don't wanna miss the next lesson. So on this lesson, we're gonna work on Newton's law. This is question 2 of your question paper. If you're doing grade 11 or you are in grade 12, this is the best lesson for you. So let's look at this question. We will try to analyze what we are given on the question, and we'll take everything step by step. Okay, so they say that we have block A of mass 3 kg. It's connected to block B of mass 6 kg. So we can see that from the diagram. And now the 3 kg block is the one that is on inclined, and it makes an angle of 30 degrees with the horizontal. And block B is pulled by a constant force to the left, as shown in this diagram. And we are given also the acceleration of the blocks. So both of these two blocks will move with the acceleration of 2 meters per second to the left. And the first question, which is 2.1, they want you to define the term kinetic friction. So the kinetic frictional force is the force that opposes the motion of an object. Okay, so this is the force that opposes the motion of an object. You can also consult your exam guideline on the definition. The motion of a moving object. So in order for object to have a kinetic frictional, the object needs to move. A moving object with what? With relative to the surface. And if you give them this definition, you'll definitely get that 2 marks. Right, that was 2.1. Let's look at 2.2. 2.2 says that the kinetic frictional force acting on the block AB. So we are given, I'm just gonna note this down. What are we given? The Fk for what? The kinetic friction for block A. It's given as 4.3 newtons, and we are given the Fk of what? Of B, and it's given as 7.2 newton. So now on 2.2, they want you to draw the label free body diagram where you will be showing all the forces that are acting on block A. So which one is block A? The one that is on inclined. So the block A, first let's draw the vertical component. Remember, if I have an object on inclined, this object is in contact with the surface, so it will have what we call Fn, the normal force. Then it will have the weight acting down, so this will be my Fg. So this is what we know so far. We have the F, which is the normal force. This force is acting up because it should be perpendicular with the surface. Then there will always be Fg acting downward. This is Fg. I'm not gonna include the components, Fg perpendicular, Fg parallel. No, I won't include the components. So this force is moving up. This tells you that the frictional force will act downwards. So this will be my Fk. Because it's moving, I'm gonna call it Fk. So let's include this, which is the force that is parallel to the incline. So we have the tensional force that is acting up there. We have the tensional force. So this tells you that we only have 2 parallel forces. So this will be my tension. And you'll definitely get the 4 marks by showing them all those forces. Okay, let's keep moving. The next question, 2.3. 2.3 says that they want you to calculate the magnitude of the tension in the string. So, ladies and gents, I need you to work on this type of questions in this way. look at this. They want you to calculate what? The tensional force. Remember, the tensional force is your horizontal force. You're gonna first draw a free body diagram indicating all the horizontal forces. Right, so we're gonna have my tension going up, and then we have the frictional force, which will be my Fk going down. So look at this. Are these the only forces that are acting on the object? The answer is no. So this is where most learners make mistake. Each and every time when they do calculation, they forget to include the Fg parallel, the weight that is parallel to the surface. So we need to make sure that on our calculations, we include the weight, which will always act downwards. If the object is moving up, the weight goes down. If the object is moving down, the weight goes down. The Fg parallel will always act downward. Doesn't matter if the object is moving up or down, it's always point downwards. So when we have, these are the only three forces that are acting on the object, and we are looking for tension, we're going to apply the Newton's second law, which says F net is equals to ma. Okay, so now I'm going to choose direction. I know that this is accelerating up, so I'm going to take up as positive. This tells you that all the forces that are going down will be negative. So I can say my F net will be the tension, which is the one going up, subtract my Fg parallel, subtract my Fk, equate this to ma. So by writing this down, ladies and gents, you already have a mark, right? So they'll give you mark for any of this formula. You'll definitely get a mark. So already by writing down the formula, something that you never gonna get it wrong, you have a mark, 1 mark down. How many marks to go? 3 marks to go. Let's work on that. So now remember, Fg parallel, if I'm working on something, if you still remember, the formula for Fg parallel, it's equals to, for the fact that you are watching this lesson where we are doing past paper, I'm going to assume that you already know that the Fg parallel, the formula for Fg is mg, the sine of theta. Please, if this is the first time you see this, make sure that you keep it in mind that Fg parallel is mg, the sine of theta, and Fg perpendicular, it's equals to mg, the cos of theta. Please don't ask where is this formula coming from. For the fact that you are watching this lesson, you are preparing for an exam, so we don't have time to do the basics. What you need to know is that this is your Fg parallel and this is your Fg perpendicular. I'm not going to talk about the things that we don't need yet in this question. So let's go back to this other side. So I'm going to say this will be the tension. We minus mg. We set Fg parallel, it's mg, the sine of theta. We're going to minus the Fk of what? The Fk of, we are working with block A, right? We are working with block A. So the Fk of block A, then equate this to ma. I'm going to explain why we chose block A. This was the first thing that I was supposed to tell you, which block to choose, because remember the tension is the same. So the reason we chose block A is that we don't know what is F, so finding F will be more complicated if we don't have the tension also. I hope this makes sense. Let's keep the ball rolling because we have a tension to find. Let's do the substitution. Remember, it was given that the Fk of what? If you can check on this problem, it was given that the Fk of that block A, it was 4.3. So I can say this is my tension minus the mass of block A is 3 times 9.8. The sine of that angle, this angle here, the sine of that angle is 30. So this will be the sine of 30 degrees. You minus the frictional force of block A. It was given as 4.3. We equate this to the mass times the acceleration. Remember, the acceleration was given as 2 meters per second. So this will be 3 into 2. So the only unknown term here is tension. So I'm just going to put that on the calculator and see what I get. So this will be 3, close the bracket, into 9.8. And then this is multiplied by the sine of 30. Right, equal sign. So the answer that we get, remember, we need to subtract that 4.3. So minus 4.3. And this gives us 10.4. So this will be 10.4. Okay, so this is minus 10.4. It's equals to 10.4. It's equals to 3 times 2, that's 6. So I just want to make sure that we did everything correctly here. Okay, I just want to verify something here. We said this will be, let me say this is minus inside the bracket 3, and this is multiplied by 9.8, and then this is the sine of 30. Then we minus the 4.3. Oh, this is negative 19. So this is negative 19. So we did a mistake when we punched the calculator, because now when I get an answer that I don't feel it in my blood, I need to check something, because like sometimes you can feel it in your blood that Norman, there's something wrong that I'm doing. So the 10.4, I did not feel that 10.4. You know why? Because I know that 3 times 9.8, look at this, 3 multiplied by 9.8, look at what you get. You get a very large number, which is 29.4. Then the 10.4 Norman, when I multiply 3.98, I know that we get a very large number. Then it will be sine 30, it's half. So half of that number we minus 4.3, you understand? So let's go back and write this down. We got negative 19. So it's 3.98 is 3 times 9.8. I think you guys get the idea, times the sine of 30. And then we minus that. Remember, this is negative. Okay. Just gonna put this inside the bracket. Let's minus that 4.3. I'm just doing this to help you practice how to get this right. So this will be negative 19. So let's work on fixing that mistake. So this is negative. Okay, I'm just gonna write down this is negative 19. It's equal to 6. Therefore, what is my tensional force? Tension is equal to 6 plus 19, because the 19 will go to the other side, which will give us the tension of 25 newtons. So when you have it like that, let's see how many marks you're gonna get. How are they going to mark this problem? So for this correct substitution here, there's a mark for that, and for substituting the acceleration, there's also a mark, and the final mark will be for finding your tension. That's how easy the question is. So let's look at 2.3.2. Now they want the force F. The force F, it's on block B. This is where we're gonna put our main focus, block B. Yo, I'm having so much fun. I hope you are also enjoying this on your side. So this is very nice. I like nice things. So this is block B, and then we need the force that is on block B. I need you to draw the free body diagram indicating all the forces that are acting on that one. We have the tensional force going in that side. We have the force going in this side. So this is my force. But there's one thing missing there. What is that? I need you to pause the lesson and try to answer me and tell me what is the force missing and in which direction is that force moving. I heard you saying frictional force, and you are very correct. It's frictional force. So the frictional force is what? That will be Fk. it will move in an opposite direction as the motion. Remember, this is going to the left, and I'll refer that left as positive. Now let's use Newton's law to find the answer. Oh, this is nice. So Newton's law, F net, it's equals to MA. So we're gonna take all the forces going to the left, we subtract what? All the forces that are going to the right. So this will be minus the tension minus the FK. Ladies and gents, there's something that we call positive marking from 2.3.1. So if you got your tension wrong, you're gonna get what we call positive marking, because there's no way you're gonna get the 2.3.2 correct if this tension is wrong. Because first thing first, you'll have a mark for substituting those formulas. For writing down the formulas, you already have a mark. Nice. So we know what is tension, we know what is the kinetic friction of B. If you still remember, we need to use that kinetic friction of B, which is 7.2. Let's do the substitution. So F minus the tension, which is 25, minus that 7.2, it's equals to the mass of block B, that's 6, which should be multiplied by the acceleration, which is 2. And now I'm just going to use my calculator to find what is that negative 25 minus 7.2. And this gives us an answer of 32.2. So this will be negative 32.2. So this will be F minus, what is this? Come on, 32.2, it's equal to 16 times, oh, it's 6 times 2, that's 12, né? So we just have to bring the 32 to the other side to be positive. This will be 12 plus 32.2, and when you add the 2, we get the force to be equal to, let's see that. So it's 12, we add 32.2, this gives us an answer of 44.2 newtons. 44.2 newtons. And this is your answer, and I'm happy with that. I'm just gonna collect the marks. Let's quickly work on how they're gonna mark the work. So you'll definitely get, you see, to substitute an acceleration is very important, and this was just 3 marks. For that acceleration, you'll get a mark, and you'll also get a mark for the final answer. Last question, ladies and gents. How will the acceleration of the block B change if the string breaks? Choose from increase, decrease, or remain the same. Guys, how will the acceleration of block B change? Look at this. I think this, I know that some of you guys, when you answer multiple choice questions, you just say anyone that you feel like, maybe just do guesswork. Oh, I like letter D because my name is Dineo, then I'll go with decrease. No, it doesn't work like that. I'll go with increase because my name is Itumeling. Today's my lucky day for that 1 mark. Doesn't work like that. Ne? You need to make sure that you analyze the question. Please don't do guesswork. And because you're going to say, it's just 1 mark. So if I'm lucky, I'll get that mark. If I'm not lucky, I'll definitely lose that mark. Yay, you are donating marks. And this is what we need to prevent. Look at the block B. It's on inclined, and it is pulling by what? It is pulling by a 6 kg block. So if I cut the spring, what will happen to the acceleration? Where will this accelerate? It will accelerate downward or upward. Where will this accelerate? So they're saying that how will the acceleration of the block B change if the string breaks? So I think that block A is moving because of the applied force that we apply at block B. So I'm going to say the acceleration of block A, it will increase. Why? Because it will move down, and the more it goes down, the more it increases in acceleration, in velocity. I hope you guys understand that. So for this one, I'll go with increase. So my 2.4, it's increased, and they don't want you to give them any reason. So tell them increase, then they'll be happy to give you that mark because you deserve it. Ladies and gents, that's it for this lesson. If you found this lesson very helpful and you enjoyed the lesson, make sure that you hit that subscription button, and by joining the family, I'll definitely make sure that you feel at home. And guys, I'm looking forward to see you on our next lesson. Trust me, you don't want to miss the next lesson.